All right, so first we're going to look at how to find the vertex given two types of equations. When you have a quadratic function that's in standard form and when it's not in standard form. So we have a function f of x is equal to a times x minus h, the quantity of x minus h squared plus k, where h and k represents the vertex. So the vertex of the point is HK. So if you notice, I have it colored here. It says the parabola is symmetric with respect to the line x is equal to h, meaning this would be the axis of symmetry, our h here, that's in the middle. And it says if a is greater than 0, the parabola opens upward. If a is less than 0, then the parabola opens downward. So any number that's in front of the parenthesis will determine if the parabola opens upward or if it opens downward. So for our example, to start off with our h and k, this would be our vertex. And be mindful of the negative sign because whenever we identify our h, we're going to always take the opposite of what we see in our formula here for the standard form of a quadratic function. So be mindful now, and I will explain this a little bit more. And then our h itself, once we identify h, that can also be the axis of symmetry. And we're going to write that out as an equation as a vertical line. And then our a determines if this parabola opens upward or downward. All right, so example 1a, it says find the coordinates of the vertex for the parabola defined by the given quadratic function. So let's look at an example of one. We have here f of x is equal to -3 times x minus 2 squared, the quantity of x minus 2 squared, plus 12. So if we want to find the vertex, help me out. What would be our h? What would be our k? That would be the vertex of this parabola. We have h and we have k. So our h being, since we're going to write it as an ordered pair, our vertex, we're going to take the opposite of our h that's inside the parentheses. So we have -2. Our h is going to be +2. And then our k, since it's outside the parenthesis, we're going to keep as is if it's positive or negative. So we have +12. So this is our vertex. Now, even though the question doesn't ask you the other information, but I want you to be able to prepare yourself as we do a complete example with everything, how to find the axis of symmetry, how to determine if this parabola opens up or down. Okay, so will this parabola open up or down? Well, look at find your A. Our A here is -3. And because it's negative, this parabola will open downward. And then if I want to find the axis of symmetry, we're going to set it up as an equation where we would say x is equal to, now look at your h, identify your h, which you said was 2. We have here x equals to 2. Okay, let's do another one. Same example here. B, we have 2 times the quantity of x plus 4 squared minus 8. What is the vertex? We have our h and we have our k. And remember, when we write our vertex for h, we take its opposite. So our vertex is -4. That's our h. And our k is -8. This parabola will open upward or opens upward because our a is +2. And then our axis of symmetry will be x is equal to -4. Now remember, our axis of symmetry is a vertical line that we're going to create. So that's all we need to know for this example. Here again, this is the standard form of a quadratic function. F of x is equal to a times the quantity of x minus h squared plus k. Okay, let's look at the next type of quadratic um, function. We have here the vertex of a parabola whose equation is f of x is equal to ax squared plus bx plus c. So this is the function that we saw a lot of in intermediate algebra. Okay. Now, and this is the function we were work with whenever we would want a factor to solve a quadratic equation. If we wanted to use the quadratic formula, we had to identify a, b, and c. We would do all of those. Um, so this is the second formula for quadratic equations. What makes a quadratic equation or function? The highest degree to the variable x is 2. So how to find the parabola's vertex for an equation written where ax squared plus bx plus c, that's all on the same side. All right, so it says here, consider the parabola defined by the quadratic function f of x is equal to ax squared plus bx plus c. The parabola's vertex. Now, this is what we're going to use. The -b all over 2a to find the x coordinate. Okay? So because here we're looking for an ordered pair to find the vertex, and to the formula that we're going to use to find the x coordinate will be -b over 2a. So here we have an example. We have f of x is equal to 3x squared minus 6x plus 1. So all we need to do right now is identify our a and b, where our a is 3, our b is -6. We just need to identify those two coefficients because we're going to be using the -b over 2a to find the vertex. So x is equal to, we have here negative times -6 all over 2 times 3 and we have 6 over 6, which reduces to 1. So we have our x coordinate, which is 1. Now we need to find y. And to find the y coordinate, you're going to take what x is equal to, which we found, which is 1, and we're going to substitute it back into the original function for x. Okay, so we want to find y. So we're saying when f of x is equal to 1. So let's plug this into our formula here. So we have here f of 1 equals to 3x squared minus 6x plus 1. We have 3 times negative 1 squared minus 6 times negative 1 plus 1. We have 3 times 1 minus 6 times negative 1 plus 1. That is 3 minus or plus 6, then plus 1, and that equals to, what would that give us here? I put negative 1 here. Let's change this. This is 1, 1. There we go. I corrected my mistake here. So 3 minus 6 is negative 3, plus 1 we have negative 2 as the solution. So our y coordinate here is 2. Okay, so this would be our vertex. Okay, and whenever we have an equation that is written in this format, not in standard form, ax squared plus bx plus c, this will be the way to find the vertex. Okay, so let's do another example. Okay, let's do another example. B, still on the same page here, we have f of x is equal to negative x squared plus 2x plus 6, and I want us to find the vertex. So identify your A. Here is negative 1. Identify your B. This will be 2. And we're going to use the formula negative B all over 2A to start off and to find the x coordinate. So we have x is equal to negative times B over 2A. We have negative times 2 over 2 times negative 1. We have negative 2 divided by negative 2, that gives us 1. So for our vertex, our x coordinate is 1. Now we want to find the y coordinate. So how are we going to find y coordinate? Well, we're going to substitute 1 in for x back into the original um, equation. So when f of 1, meaning we're going to substitute 1 in for x, we're going to plug it into our formula. We have negative times the quantity of 1 squared plus 2 times 1 plus 6. Then this is going to give us negative times 1 squared. That will give us negative 1. Then we have 2 times 1 plus 2, and then plus 6. And then we add these together. Negative 1 plus 2 is 1. 1 plus 6 gives us 7. So our y coordinate would be 7. Now, because if you look at our A here, because it's negative, that means if we were to graph this question, the parabola will open downward, where the highest point of this parabola is at 1, 7. Whereas the previous example that we did, we just completed, our a here is 3, is positive 3. So this graph would open upward, where the lowest point would be at 1, 2. So our next set of examples, we're going to look at how to graph a quadratic equation when it's written in standard form and when it's not written in standard form.